Hello friends and hello student. My name is Ashok Sijala. In this session we learn the decimal number convert into binary number in C language. So let us start. First I share my laptop screen and here fix the goal. So here my screen fix in position so you can watch my video better way. And here turbo C++ is there. I just double click and take some process and now yes it's open. Alter F file menu taking and take new file, and here our definition write a uh, yes, program to, you can say that, enter decimal number and convert into binary number. Okay, so that is our definition. Write a program to enter decimal number. So you have to know what is a decimal and convert into binary 0 1, that binary number. So here we can use the one dimensional array to store the our binary number, convert that number. So how that possible? You have to know the, you can apply the division operation and then that reminder value you can in reverse order you have to print. I think you have to know manually, I think. So if you not, then I give some like example. So like we can divide 8. So we can divide the 8, so divide by 2. So that is a 4. Okay, so means 4 divided by 4 to the 8. So that is a divide by, then 4 divided by 2. So 2 to the 4, yes, and then 2 to the 1. So at the last, that is 0. So all division that our reminder we have to take in storing that value in reminder in our array, and that is a divide by number. So there are two operations, modulo operation and division operation. So we can divide by 2. So first we can take the modulo and store in our array, and then division operation. So that same number, and we can take index as an I plus plus. So I think you have to know how to convert decimal to binary. So here we can apply to our programming logic. So here, yes, conio.h and then void main. Yes, so and now we can define some variable, and that is we can take one number from decimal number to user side. So we can say that d number, dn, decimal number, that meaning. And then we can store 1D array. So here we can take like 10 size or any big 20 or that type of size, and then we can take one I and initialize to 0. That is our index of array. Yes, array index always start to 0. Then clear the screen, and we can scan to our decimal number. So here we can give the suitable message. So enter the decimal number. So we can must be enter the decimal number, and we can scan, yes, percentage d and ampersand dn, decimal number dn. That you can also give the n only, but no. And here that number programming. So uh, convert decimal number into binary number. Okay, so that is my technique. I first write here my technique input. So input is a one decimal number that we have already done, and then process. So we can use the division and modulo operator, because division and modulo is a taking the remainder and division operation takes. So we can find our binary number, and then output number. So means output of decimal to binary. That is we have to print. So that is in between process how to convert. So here always we have to take the while loop, because that number programming, not a like a pattern, triangle. 1D array is there, but we can also use a for loop, but in printing, but we have to develop our logic that while loop. So here dn is greater than 0, that is our main while loop. Every my number program I take the in almost that type of while loop greater than n is greater than 0. So here decimal number, so dn is greater than 0. So we can store our XOR because already we can assign I to 0. So here we can modulo, yes, so dn modulo 10. So our that is storing, yes, and then we can divide dn to equal to divide, or we can also use the short technique like division or equal to 10. No, here we can apply the 2 because we have to not so binary, so there is a require only 2, yes, not 10. So uh, and then I plus plus, so that is a we can increase our we can say that index, otherwise I plus plus is not there, so we can provide the I plus plus. And what is a full form this statement you have to know very well. Dn equal to dn divide by 2, because decimal we can convert to binary, decimal convert into the binary, so we can always take modulo 2 and division 2, and then we can print to our binary number. So here we can give the message the binary, yes, number is, and percentage not just message, we can, that is a 1D array we have to print, for loop we have to print. But you have to know very well, in convert the decimal to binary we can in take division is a sequence, but write in the that module in reverse order. So we can like I and equal to I minus 1, because that last plus plus is not work, because after that condition one time increment more I plus plus, so then after that loop is terminated, so we can minus 1, okay, in I. So one time is a one additional means one extra I plus plus, then our if condition we can trace our logic, then you can understand. So here I is greater than or equal to, we can say that 0, and then I minus minus in reverse order we have to print. So then our binary number is a printed. So here again that we can give like percentage d, and then we can print to our x of I. Okay. So that is a print, and then we can provide the gets here. So very simple logic I developed. So here we can, and yes, I save this file. So here we can say that decimal to binary. So here 8 character is there. Yes, 6, 6, and 8. Or you can underscore is allowed. So decimal to binary, we can say that, and dot C or 2 word also you can use. There is no problem. So decimal to binary number. Okay. So dot C extension. Yes, first we can take our any like 8 we have to give. So like that binary is a 100. Okay. So that I think 4. So yes, let us check that number. So yes, we have to take the decimal number 8. So yes, that 1000 means that is perfect. That giving the our binary number, but that are concatenation. So we can provide some blank. So here I give the 4 or 3, 4D. Let us check how many gap. That is a width. So here I again give the 8. So yes, that look is better. So decimal number 8 and binary is a 100. Yes. And we can check also different number, like I give the 9. So that is 1001. Yes, I think that perfect. So you have to, yes, any number now you can scan and print. So 101, that 5. Yes. So that is a binary number to convert to decimal number. So how it's possible? Let us check in watch window. So here I provide the W and alter W and take watch window, and then also output window. So here you can some crease is size that small, and here we can take to our first DN decimal number, yes, and then X of I, that our store binary number, and then our I, that is a index means our array. And yes, we have to use only three variables, so all we have to set in our, and we can start to directly here. So control F8, that red line, that is indication that we can start our trace line by line in this line while loop. And what is a F7 here? F7 is a trace information. By control F9 first run, and I press the 8. So how that is a work? Let us check that 8 decimal number convert into binary. So here that dn is store 8 and then condition is true definitely. Yes, then that modulo operator 2. So what is a store? That is a divide by 8 divide by 2. So remainder is a 0. So yes, that store x of I is initially we can provide the here 0 starting I equal to 0. So yes, here also 0 because modulo that remainder is 0 and then divide by 2. So 8 divided by 2. So that take now new number is a 4. Yes, 4 is there. And then I plus plus. So I is 0 and then now 1. I plus plus. So 1. Yes. Then again dn new number is greater than 0. Yes, that is 0 greater than 0. So modulo. So 4 divided by 2. So that is a remainder again 0. So that is a store in the first I is 0. Now I is 1. So 1 store again the 0. Yes. And then divide by 2 or 4 divided by 2. So that is a new number is a 2. Yes, here is a 2. You have to know. And then I plus plus. So I is 1. Now 2. Yes, again greater than 0. Yes, our number is new number is 2 and greater than 0. Yes, so here again 2 divided by 2. So that is a store modulo is a 1 reminder, not 0 at that time. So here is a that is a 2 divided by 2. So yes, that remainder is 0, but division is taking one number. So yes, that last time I means that loop is true. Yes, because I plus plus, so I is a now is what happened 3. Yes, and then condition is true. So now is a that is giving the 1 3 are 0, but that reminder is first now is a store in 1. Yes, so modulo in 1 divide by 2, so that is giving the 1 at itself reminder. And then now new number is a divide by 2, so 1 divide by 2, so that is a 0. And then one time is a here 1 I is a extra plus plus because our 3 0 and 1 is already stored in our 1D array, and here that index 0 to 3, so that 4 element. So 0 0 1 at the last one, but we can print in the first. So here we can in reverse order, and here one extra I plus plus, and then loop is a false. Here now condition is not equal to, so dn is 0, so that come back, and then first here I is a 4, so we can minus 1. So I equal to I minus 1. So 3 and reverse order we have to print. So here directly assign the I is a 3 and 3 index store the 1. So that is our goal. So here now 4D. So some blank and at first print the 1. One store at the last, but print in the first side because we can reverse order our for loop. So in I minus 1, so I extra 1 we can minus 1. So that is a 3 index because 4 our element is stored in the 1D array. So now 1 is first print. Yes, that 1 here you look in the output window, and then I minus minus. So 3 to I 3 is previously I, now is 2. So 2 store of that element is 0. So 0, yes. And then again I minus minus. So 1 positive means index that is store 0 element. Yes, again 0. And then again yes I minus minus, so 0. Yes, last time greater than or equal to here is, so last 0 is print and our 8 binary number is print. So here we can perfectly simple logic develop. So any number you can enter decimal that giving the binary. So here go that red line position and remove this red indication. So we can remove our watch window and complete. So very simple, write a program to enter any, means any your word, you can also write any decimal number. Okay. So any decimal number and convert into binary number. So means decimal number. So here we can go give the 12. So that is 1100. Yes. So we can store in first in a uh, sequence, but print in the our reverse array. Means that for loop we can take in reverse, but one extra that is a maintained to here. So we can initialize I itself minus one I. So that is a here one extra I plus plus, then loop is terminate. So here we can solve all problem. Otherwise that one garbage value. So that is a happen. So I think very simple here, and also you can all that type of programming. Okay. So decimal to binary, binary to decimal, that type of your convert CFET, that computer fundamental, you all number means that conversion is there. So here decimal to binary in we can use the 1D array and store and print, and taking the while loop and for loop both in one program. So that is our logic. And here our output is also some logic. We can minus and then initialize, and reverse order we have to think. So I think you have to know that is our input only one decimal number. That is our process, means that logic. You have to know we can divide by the decimal number, divide by 2 and taking the modulo, and that means reminder. So we can take modulo operator. So only here two main operator use division and modulo operator, and I is a index, so we can plus plus in while loop, and then we can print to our binary in store in array. Okay, so write this program to your note, very simple, that our definition, enter the decimal number and print in binary. Again I run and take some different number, like you can identify, like we can give the 4. So 100. Yes. So yes, that is a perfectly work. So let us check again. I give the 15. So that is a 111. Okay. So all number you can test to yourself. Very simple logic I develop, and that is a compound assignment operator you have to know, and that is that full form. So I close this file. Yes, and also our watch and output window and quit. So subscribe my channel or Shukshijal Academy. Press the bell icon to never miss any update. Thanks for your watching, supporting, and sharing my video lecture. And Hare Krishna.